Okay, so let's do a couple more examples where we're still solving for x, but in this case it says find all solutions. And what that means is we don't want solutions just between 0 and 2 pi. Now we want all solutions. So if I wanted to go around the unit circle 3 times, where would that solution be that would fit for this equation here? Okay, so if my period of the original trig function is 2 pi, so think about back in chapter 4 when we were graphing, if the original period is 2 pi, then all I really need to do is add 2 n pi to my answer. Because the period is 2 pi means that answer is going to repeat every 2 pi times. Okay? If the period is pi, like in tangent and cotangent, then I'm going to add pi. Ooh, I should have put n, but I'll put pi times n. Right? So the tan and cotan answers repeat every pi times, right? So I'm just going to add however many pi's I need. 1 pi, 2 pi, 3 pi, plus my original answer. All right, so let's look at a couple of examples. We have 2 sine squared x plus 3 sine x plus 1 equals 0. Here I have only one trig ratio, but now it's squared, sine squared. So this really looks like a quadratic equation. And what I'm going to do is use u substitution just to simplify the equation a little bit so I can solve it a little faster. So if I use u substitution, all that means is I'm going to take out sine, which is a function. It's one big term, but I'm going to rewrite it as u just to make the problem look a little easier. That means if I have u squared, that's u times u, that would be sine times sine, which is sine squared. Okay, so now I have, instead of 2 sine squared, I'm going to have 2u squared plus 3u plus 1 equals 0. Anytime I see sine, I replaced it with a u. Now this looks a little more familiar to maybe an Algebra 1 or Algebra 2 class. A quadratic that I'm setting equal to 0, I can use quadratic formula. I can factor to try to figure out what u equals. I'm going to use factoring. I need two numbers that when I multiply I get 2, and when I add together I get 3, and those two numbers happen to be 2 and 1. Okay, and because I had to multiply by 2, there was a or a number in front of my squared term. Just going to divide both sides by 2u, and because this simplifies I get 1 over 1u. So when I factor this guy, I'm going to factor it to u plus 1 times 2u plus 1. And of course, you can use factor by grouping, you can use box method, any method to factor, or like I said, quadratic formula would also work and give you your answers for u. Here to get my final answer for you, this is the factored form, and in order for these two factors to multiply to 0, either the first factor, u plus 1 has to be 0, or the second factor, 2u plus 1 equals 0. Then I solve, I subtract 1 from both sides, I get u equals negative 1. Subtract 1 from both sides and divide by 2, I get u equals negative 1/2. And so my answers for u are here, but my original problem had sine x, and I'm supposed to solve for x. So let me go back and replace u with what it originally was. It was sine. Okay, so now I have my answer for u. I'm going to go back and substitute in the original equivalence of u. So instead of u, let's replace it back with sine x. So sine x equals negative 1. And here I get sine x equals negative 1/2. And now I can go to the unit circle. Now this is way easier to solve than trying to come up here and factor. So now I have sine x minus 1. I look at my unit circle, and the only place where sine is negative 1 on the unit circle from 0 to 2 pi is at 3 pi over 2, down at 270 degrees. I'm using radians. You could use degrees. It doesn't really specify in this problem, so it's really up to you. Then when I look at sine x equals negative 1/2, there's two places where sine is negative 1/2. So I go to my unit circle and I say, well, I know in quadrant 1, at pi over 6, sine is 1/2. I don't want positive 1/2 for sine, I want negative. So I need to use this as my reference angle, pi over 6, and go in the third and fourth quadrant and find my answers. So in the third quadrant, I'm pi over 6 below the x-axis, so that'll be 7 pi over 6 is one of my answers. And then in the fourth quadrant, I'm also pi over 6 below the x-axis, which will be 11 pi over 6. Okay, so my two answers are 7 pi over 6 here, and then I'm going to put comma 11 pi over 6. I left a big space here because remember, we weren't looking for answers just between 0 and 2 pi. We're looking for, well, if this is one of my answers, what if I wanted to go around the unit circle a couple of times? What would that radians actually measure? Okay, so I'm going to put plus 2 n pi because sine originally has a period of 2 pi. So I'm just going to add 2 n pi to all my answers. So now this is the form of all the multiple answers we can use for x so that this equation is true. All right, let's try one more. So we have sine of 2x now equals negative root 3 over 2. I'm going to use the same technique of the u substitution, but this time I'm going to substitute the angle. Instead of 2x, I'm going to let u replace that 2x. So now I'm just looking at sine of u equals negative root 3 over 2 and just solve it like I would normally solve. So I see sine of u is supposed to equal negative root 3 over 2. I look at my unit circle and I say, okay, I know at pi over 3, sine is root 3 over 2, but I want negative root 3 over 2. So that means I need to be, pi over 3 is my reference angle, but I need to be in quadrant 3 and quadrant 4. Right, so I'm pi over 3 below the x-axis, which would be 4 pi over 3. And I'm over here in quadrant 4, pi over 3 below the x-axis again, which would be 5 pi over 3. So these are the two locations where sine is actually negative square root of 3 over 2. So my u equals 4 pi over 3, comma, 5 pi over 3. And again, I'm leaving that big space because we're looking for all solutions, not just between 0 and 2 pi. So let's say I wanted to be here, but I wanted to go around the unit circle a couple of times and land here. I want to know what that answer is going to look like. And again, sine has a period of 2 pi, so I'm just going to add 2 n pi and 2 n pi. Put a little line here. So these are my two solutions for u, but remember I used u substitution. I was trying to make the problem look a little easier for me. So I need to go back and replace u with what it originally was. It was 2x. So now I have that 2x equals 4 pi over 3 plus 2 n pi. It's one of my solutions. Okay, and then I'll write over here, comma, 2x equals 5 pi over 3 plus 2 n pi. And in order to solve for x, we know that last step, we have to divide by 2 on both sides. So now I know that x equals, if I divide each of these pieces by 2, 4 pi over 3 divided by 2 becomes 2 pi over 3. Or, sorry, divided by 2, sorry, it's like times 1/2. So yeah, it's 2 pi over 3. And then plus, when I divide here by 2, I get n pi. And I'll do the same thing here. When I divide by 2 on both sides, I end up with my other answer for x. We'll put here equals 5 pi over 3 divided by 2 is the same as 5 pi over 3 times 1/2. So I'm going to write that as 5 pi over 6 plus 2 n pi divided by 2 is just n pi. So these are my two forms of solutions that when I plug any kind of angle of this format in here, I will get that my sine of that angle equals negative square root of 3 over 2.